Welcome to NeuroNoodle's Neurofeedback and Neuropsychology Podcast, featuring tech legend Jay Gunkelman. He's the man who has read well over 500,000 brain scans, and Dr. Marie Swingle, author of iMinds. Our goal is to provide information and promote options for better mental health. The NeuroNoodle Podcast is supported by listeners and businesses just like you. Jay Gunkelman.
Hello, hello.
Jay Gunkelman, what I would love to see is a hat with a bunch of strips of paper in it with numbers corresponding to unforeseen PowerPoints that you've done in the past that you could just pull out and say, this is what we're going to do today. I don't even want...
We've got a pile of stuff. And, I mean... gamma and EEG and neurofeedback. This is a hoot.
All right.
Homunculus art. Ooh. Homunculus art. The three-dimensional or two-dimensional representations of a three-dimensional image of the homunculus.
All right.
And so it's basically the strip here, and you normally see it like, the toes are hanging down, the butt's at the butt's at the top here, pretty good sized hand, a face, and then the tongue inside of the mouth all the way into your gastrointestinal motility and GI system and the insula. So this is how it's normally laid out. And you can always tell a motor homunculus from a sensory homunculus. You know how?
No. See
the genitals?
Oh.
You don't have those on a motor homunculus, Actually, Ramachandran did a talk on stroke recovery, and he was talking about motor system, and he showed this. And I waited to after his talk was done, and most of the folks had a lot of people ask questions after a major speaker talks, and I waited till it was like there wasn't really people around, and I said, you may want to check your slide deck because you used the wrong homunculus. The one you used had genitals. It was a sensory homunculus. He said, you're kidding. And he went through his slide deck, and sure enough, there it was. I mean, you can't miss them. And you can see maybe the people that have a feet fetish have something, so they're right there, but anyway, there's a lot of people. First of all, there are newer renditions that have flexor extensor pairing around the hand and motor systems, and those are more accurate because your motor system is set up in flexor extensor pairs. It's not just your hand, everything that moves in your hand. Every finger has a flexor and an extensor muscle system associated with it, assuming they're still intact. So you can create a 3D sensory homunculus, and you can see it's sensory because it actually has a genital on it. But you can see the face. Now, if you look at the area of the homunculus, topographically on the cortex, it's associated with your sensory sensitivity or your motor expressiveness. Now, you're a lot more expressive with your hands. Some people use like one digit a lot more than others, but your hands are quite expressive. So is your face. When was the last time you saw a happy back or a kneecap that looked joyous? I mean, there are parts of you that are expressive, and there's parts of you that are just hanging there, taking up space, not intended for expression. So the layout, how much of the turf. You see the skinny little arms and his scrawny little legs. The feet are a little big. He's got clown feet, floppers. But the large mouth and face and tongue, because you have a lot of sensitivity there. Now, if they did it, correctly, there'd be you'd actually see down inside, but that's hard to do. Here's another rendition. This is motor, and you can see they just kind of ignore the genitals on this one, and the feet for that matter. But again, large face, the parts of your face that you have good sensory and motor control over. When was the last time you had an itch on your face and you couldn't find it? You just reach up and you scratch the damn thing. But get an itch on your back. You can't find that sucker. You scratch a little up, a little to the side, a little to the other side, a little down, a little over. You scratch the hell out of your whole back, and you can't even get the damn itch. So your specificity for sensory sensitivity spatially is also fairly well restricted to the areas that have more turf. So you have an itch on the back of your hand. It's not hard to find it. But if you have an itch, in the middle of your back, good luck. So anyway, we've got a homunculi, of multiple homunculi. This one apparently thought that the sensory system was particularly well endowed, and there's no accounting for this. This is just the artist's rendition, So
Yeah.
who knows?
Homunculus envy.
Anyway, I've got all sorts of odd PowerPoints in here.
Floats your boat this morning. What are you in the mood for?
You know, have you ever seen the demonstration? At some point in this, they're going to skewer this guy with
Oh, geez.
it's starting. They're going to stick this skewer down through his jaw, and he's having trouble getting it through his jaw. So there's people there to help. They're going to grab his head. They're going to jam this sucker down through his jaw. Anyway, yeah, down through and then back out. It's got another shot.
Oh,
Anyway, this was a demonstration of pain control, but quite honestly, to me, it didn't look like he was terribly comfortable. And
talk about a cavity.
What a shot to join in on.
Welcome, Dr. Marie. You're
Good morning.
so
Jay,
he's smiling though,
Jay showing us his dentist.
Yeah.
This was done at a APB meeting, and you can see they have that down clean through his jaw, sticking out the bottom. But as you could see, it wasn't a comfortable experience for him. Kawakami, on the other hand, stuck skewers through his neck, in, out, and up through his tongue, and showed no response at all electrophysiologically. So Erik Pepper has done a number of these. You can see he's got one stuck through his pectoral muscle as well. Anyway,
Did anybody hurl?
no problem taking it out. Here's Miramatsu. These are various healers, and this is a paper that was actually done on a healer, and this, he's a healer. He's smoking cigarettes, and it's not. He doesn't have the aura of a healer around him at all. But nevertheless, this is Kawakami, and this is actually a demo where he's being having his physiology displayed, and you can see the skewer through his neck and through his tongue. This was not, this is the meeting in Hasselt, Belgium, and this is not the screen that we were showing when he was doing the stick. That it actually had EEG at the lower left corner, but he didn't seem to have any pain or bleeding of any sort. And what basically he does is the somatosensory strip of the brain goes electropositive, which turns it off. And then he does the stick, and then he turns back on his somatosensory area. And there's a DC potential shift, and it goes more electropositive to turn off and more electronegative to turn back on. There's no orienting response. Normally if something happens, you have an activation or an orienting response, and he doesn't even have an orienting response to sticking himself with his skewers. And anyway, there's this is a healer, busy healing low back pain or something, kidney problems, whatever. But these kinds of things end up happening at various meetings. So, but we were just going through, looking at odd circumstances. We looked at the homunculus models that are out there.
Where did Jay? I thought that was pretty interesting. Where did homunculus come from? I don't even know what that means.
Homunculus means a little man.
Ah,
and
so I'm the anti-homunculus.
So, and it's just the little image on one side and the other side of the somatosensory or somatomotor strip. And as I pointed out, the difference between the sensory and the motor is the presence of the genitals. And they're right next to the toes, way deep down in the central fissure, and they're present in the sensory homunculus, but not the motor homunculus. And I mentioned to Pete that Ramachandran did a talk on stroke and actually showed the sensory homunculus instead of the motor homunculus. And
those are the interesting ones. But I'm not sure I can add anything to the tongue piercings and the like. It's kind of out of my repertoire.
Well, that the homunculus historic ones didn't display flexor extensor pairs. Yeah. And there's an updated homunculus that ends up having the hand area with flexor and extensor pairs kind of going out from a center point. And but that's how the body works. It's not just a hand. Your hand area has flexors and extensor muscles, and they work in opposition, unless you just are rigid or stiff, in which case they're all activated at the same time. I don't know if you remember Bernie Brucker.
No.
Bernie unfortunately passed quite a few years ago now. Bernie was one of the original EMG specialists, and he was out of Miami. He was quite a character. You never saw him out of a three-piece suit, and quite often a black cowboy hat. And he was very dark-skinned. I'm not sure of what heritage, but he flew jets over the ocean looking for people coming in from for the Coast Guard in his spare time. He was really quite a character, but he taught people how to regain movement after strokes, and many years sometimes after strokes. He had a fellow who couldn't move his hand from a stroke. He taught him how to operate his hand again. He played a concert in Carnegie Hall. It taught people that were wheelchair bound how to walk. He did fabulous rehab work on flexor extensor pairs. Some cases, the person had been paralyzed for so long they were in contractures. Their body had seized up, and the contractures actually have to be released surgically so that you can get movement in the limb again. And it was hard for him to get surgeons to release contractures when they said, well, he's paralyzed, he'll never move it again anyway. And he said, yeah, I will. Release the contractures and I'll get his arm to move again. So he was really quite good, really advanced ahead of his others in his era. And he was just starting to work on the brain muscle interaction, unfortunately, when he passed unexpectedly.
Mm-hmm. Yeah. I want to give a shout out to Gabe Sella on this as well. I remember going to one of his lectures where he was actually challenging a little bit the extensor contracture. If anybody remembers his work on that, maybe we should yap with them, but it was a really interesting perspective in terms of how they weren't as paired as we thought. Jay, does that ring a bell with you at all?
Gabe Sella's work, yeah. There were quite a few people that had interesting EMG, surface EMG work. Now, EMG medically is done with needle electrodes. They'll stick you with an electrode with just the tip of it not insulated, so that when they stick it, they can actually see activity from a spot that they stuck it in. And they measure EMG to look for fasciculations in ALS, what kind of paralysis might be present and those sorts of things. So motor neuron disease ends up being tested using that quite often. And but surface EMG, on the other hand, was looked down upon by the people who were doing needle EMG as being inaccurate or not, worthy of, being looked at.
It wasn't invasive enough. Yeah.
But most people in neurofeedback, biofeedback world think back that, oh well, late 60s, early 70s, Stoiva and Budzinski, those were the people that started EMG feedback. But there were 25-year follow-up studies by Dr. Whatmore at the time. George Whatmore and Dan Coley. Coley was the engineer. They built an integrative neurovoltmeter so they could measure and quantify the EMG. Now, they still stuck needles in, but they quantified everything, and they looked at muscle tension patterning across the body in different psychiatric presentations. And schizophrenia, they found peripheral muscle tension, legs and arms, to be extremely excessive. And for normal neurotic stuff, the frontalis. For depression, the masseter. They had very interesting, the range of variability and mean of the various groups didn't even overlap. It was really strikingly distinct in separating groups one from another. Anyway, he had 25-year follow-up. His book, The Pathophysiology and Treatment of Functional Disorders by Whatmore and Coley. And the book was from the 1970s, but it goes back to the 1950s when he started and did follow-up studies on his clients. So a lot of interesting early work.
Okay, what's going on in the brain that the pain's getting blocked? Like, can this guy go do open heart surgery and just, block out the pain? Or
so your cortex operates. You see all the AC oscillatory stuff in the cortex, and you see that cortex is busy doing something. But the slow cortical potentials can turn off cortical function. The phase of the infralow frequency can turn on and off cortical areas, which is how they can stop seizures using slow cortical potentials. But it's also capable of turning off somatosensory. So when you go electropositive, all the AC dance is gone. And when Kawakami was doing his stick, his trick was to go electropositive over the somatosensory strip, turning off sensation, do the stick. Once the skewer is stuck through, well, you've probably had an IV stuck in before. The only real pain from the IV is the prick going in, or maybe the prick doing the stick, one or the other. I don't know, but it
We'll let
hurts
it get
going
on.
in. But once it's in there, they tape it down, and you can lay there with an IV in your arm, and it's kind
I'm
of.
going to be the wimpy redhead. Those of us with very fair skin, no, no. We have different pain.
But redheads are also supposed to have a very high pain tolerance.
Yeah, we're an absolute contradiction in that regard. Anything on the surface of the skin is one thing, but on the interior, yeah. Actually, some interesting stuff in terms of the great warriors, whether it's Boudica, Erik the Red. There's a lot of redheads who have been through forms of mutilation and done okay. So hey, not to give anybody any ideas, but the IV, I tell you,
Yeah.
the sun and the IV, they're dangerous.
Yeah. But the ability to literally turn off pain is a very important skill set, because there are people with chronic pain that need to learn how to turn it off.
Yeah.
And the chapter we wrote in the Cambridge University Press book on non-pharmacological pain management, and we've got a chapter in there about hypnosis, neurofeedback, other non-pharmacological techniques, stimulation techniques, and so forth. Gabriel Tan, Mark Jensen, myself, there was one other author. It's been quite a few years. I can't remember the fourth author.
Hey, would you mind expanding on that? Because that's a huge population that all of us work with. I know a lot of the work that I do is just in terms of quieting. But can you expand a little bit in terms of how you work with, I don't want to say somatic forms of pain, but pain messaging that's just much louder than the condition?
No, in pain medicine, they've looked at the EEG carefully now, and they have a fairly good understanding of the thalamocortical dysrhythmia associated with chronic pain. The location that has the chronic pain, the alpha frequency slows down to the theta frequency band. It turns off lateral inhibition, and you can have the adjacent area in phantom pain. Stimulating your face makes a pain in the arm that you don't even have. So there's been neuroplasticity, which is helpful for operation, but it goes awry when there's a lack of input. So tinnitus, phantom pain, movement disorders, reward deficiency and depression, all of those are thalamocortical dysrhythmias. In pain, there's a dysrhythmia in the somatosensory area, but that dysrhythmia also can occupy the anterior cingulate. When it occupies the anterior cingulate, it's called, in pain medicine, it's called the distress network or the suffering. Now, it's the same as your salience network. There is not a different network. That it isn't like they've got their pain medicine has its own little network up there. This is the ability to over focus on the thing that's making you feel the pain. What happens when you focus on the pain? You amplify it. It's like the Bereitschaft's potential up front for movement. When you intend to move, the surface of the brain lights up with electronegativity, which helps movement. So you prepare. It's a readiness potential. The Bereitschaft's potential is intention to move. Well, in a sensory area, the same electronegative shift happens when you intend to perceive, which is called attention. So intention up front, attention, and sensory areas. And if you pay attention to the sensory input, you amplify it. So in pain medicine, if you can get rid of the suffering or distress by getting rid of the anterior cingulate's involvement in the pain, you may feel sensation without the distress. Now, that's what I've got. I've got so many things that are totally screwed up. When you cut off 4 fingers and have them stuck back on, and there's no joint there. It's just bone on bone stuck together. This is my good hand, and this hand, they wanted to fuse the wrist last time they were in there. They took all the cartilage out of the wrist because they unfortunately stuck when a bone was shattered with a head-on motorcycle car crash that I had. I was on the motorcycle. That it shattered a bone and the bone died, so they had to take the bone out. And at the time, they had this brand new implant from Dow Corning made out of silicon. So they put that in at the base of my thumb, and I had a breast implant problem in my thumb, in my wrist, essentially after that. And silicon was shed throughout the wrist. My wrist was, 3-4 inches thick. They put a zipper on the back after they went through the front a few times trying to drain things out. They finally realized that the implant was the problem. So they took the implant out. I don't have a bone at the base of the thumb at all. And they had to carve all the cartilage that had silicon on it out of the wrist. So it's bone on bone on bone for the entire wrist. Osteoarthritis, bone on bone, what that feels like, it's painful if you pay any attention to it. But when you don't pay attention to it, it's just a sensation, and it's not painful. It's a sensation. So
you don't have a little redhead in you there, Jay?
In my beard, I have a little red, but it's turning gray. So, and I broke my back twice. I got my ribs all busted up. I got bad knees. Before the brain tumor, they said one more thing wrong with you, you'll be a monster. And they were right.
Monster Jay. Then what's going on with fibromyalgia? What's going on there?
Yeah.
Well, fibromyalgia is a complex circumstance where people have pain in muscles, not just like, I went to the gym and I worked out and I overdid it with my shoulder and I got pain in my muscle over here. They have chronic pain in their muscle because it's not a muscle contraction pain, it's a muscle spindle pain. You think, well, what motor neuron moves this? Well, it's your motor neuron, isn't it? Yeah, but the muscle tone is sympathetic innervation, not motor innervation. So you can hold excessive muscle tone, kind of like going to the gym and taking a 5-pound weight and holding it out straight. 5 pounds is nothing, but wait another 10 minutes and see what your shoulder feels like. Chronic low-level tension, tone, is enough to create chronic pain. And if your sympathetic nervous system, the insula on the left side, anterior insula left side, isn't doing its work properly, you can end up having all of the sympathetically innervated muscle spindles tense up your muscles. So you're going to have trigger points. The muscle spindle is going to be a little spot. If it's poked, it's going to hurt. And the trigger points are muscle spindles. They're sympathetically innervated, not motor neuron innervated. You'd think, well, just relax. Well, what's relaxation? The lack of a motor neuron command? That gets you down to your muscle tone, but it doesn't get you fully relaxed. So you need to learn how to control not just the motor neuron, but also the sympathetic.
Hey everyone, if you're enjoying the show and want to help us keep it going, please consider supporting us on Patreon. Your support helps improve the content and brings on great guests and grow the show. Join us on Patreon at patreon.com/NeuroNoodle. But hey, if supporting financially isn't in the cards right now, no worries. You can still help us out for free by liking, subscribing, and sharing this episode. It really makes a difference and helps more people find the show. If we've earned it, hit that subscribe button and turn on notifications so you never miss an episode.
innervation. And that's the part that's tricky. And HRV, why in the hell would your breathing and HRV training fix your motor system? Well, because of the sympathetic innervation. So if somebody has fibromyalgia, they need to be seen professionally. But the neurofeedback world has techniques that can end up assisting with fibromyalgia. If you're not getting relief from your doctor, try to find somebody who's working in biofeedback. This is not necessarily EEG. This is HRV, electrodermal, that peripheral, quote, peripheral style training. I don't know who came up with that. Peripheral to who, So this seems like a start of the same person to me. But fibromyalgia, you'll feel where you poke the muscle, you feel specific pain. There's ways to inject a sympathetic blocking agent to get rid of that muscle tone excess, and that same technique is being used in Hollywood for people who don't want to use Botox because you lose the ability to emote. The joke comic of Botox happy, Botox sad, Botox angry, the same exact face. There's no ability to express. There's no wrinkles on the forehead, but you can't furrow your brow to express something. So in Hollywood, you can't be a Botox star because you're going to be a Botox face, and you can't emote. So the very expensive technique of having a neurologist probe around and with a syringe wired up as an electrode to find the muscle spindle. When you hear the muscle spindle fire, you tap the syringe a little bit and paralyze the muscle spindle. The muscle still works. You can make all the faces you want, but the muscle tone is gone. So all the wrinkling that you have because you're holding excessive tone instead of relaxing, those are gone.
So is there such thing as digital Botox then?
Well, it's not digital. It's
I'm
still
looking
an
for
injection.
clicks, Jay. Come on, work with me.
It's this is not Botox. Botox is a toxin. Botulism, Botox, and there's problems with Botox sometimes, migrating and paralyzing things and giving you Guillain-Barré symptoms and things like that. Little minor inconveniences of spreading paralysis and things. So it's not always, as safe as people think. It's just, a simple cosmetic procedure. I don't like my wrinkles, so I'm going to paralyze my forehead. Maybe it'll get your eye. So
Well, there's also something else going on, Jay, and again, this is where I'd love to discuss and kind of dance in ignorance until it becomes knowledge. But one of the things we see when we measure on the frontal lobes is for individuals who have Botox, we lose the accuracy of the measurement. Now, there's a really good argument that this is just basic muscle tension variation intervening with the readings, a form of artifact that it's too sensitive for us to artifact out. But I really wonder about, I think there's a lot more going on in terms of, when we used to talk about the mirror neurons, in terms of if you're not emoting out, you're not receiving. And I actually really feel that some of the markers are actually amplified markers of depression. Now, to what degree that is real because you can't give and receive emotion, and to what degree is there something going on in terms of those ultra minor muscle tensions that are picked up in the EEG, I don't know. But it's a big difference. It's a big difference. Any insight on that?
Well, luckily we have ICA and it takes out EMG very nicely. Which is helpful. However, it's a good theory because your mirror neuron system perceptually is not just perceiving. There's a mimicking,
Exactly.
and the subtle mimicking is not gross motor. If you see somebody reach for something, you don't necessarily make the reach yourself, but the mechanisms of movement are activated, and the meaning of the reach ends up being mimicked. And if you don't have the ability to do that mirroring, it may turn off your motor neurons, your mirror neuron system. There's an interesting data point, and I'm waiting for it to be filled out a bit more. People that have looked at the data that they've collected before COVID sequestration happened, and everybody ended up isolated, and the EEGs after that, and the amount of mu. The mirror neuron system appears to be a little more disconnected now than it was before. Now, this is a data point from a practice looking at the clients before and after the sequestration, but I think there's probably more data out there than one practice, and it has to be kind of put together a bit more to illustrate this. But
when's that coming out, Jay? I'd be really interested in that.
Yeah. And, Corey Newman mentioned their practice has seen this, and I said, well, you need to write it up. It's a case series. You've got a series. You drop a probe of a change in environmental behavior, and now afterwards you get a different outcome. It's important data, and there. If you look at all the people that are saying, well, we've got a mental health crisis now that we didn't have before all the sequestration and stuff, you've got to start to look at mechanisms, and being functionally disconnected from the outside world may foster difficult affective regulation. After all, the frontal lobes, which are where we expect affective regulation to occur, not affect perception, but affect regulation, in inhibition or initiation of actions and things like that. So if that spot's not working well, and where's your motor neuron? Motor neuron system, frontal central is the mimicking or mirroring, and that's frontal to central. And if that's not connected, you see the mu. But that's not the whole system. That's just the mimicking or mirroring. There's a comprehension loop. After you mimic or mirror and understand what it is you're mirroring, then you comprehend it. So for language, mama, papa, da, da, the little baby talk, and then finally, oh, damn, papa's that one and mama's that one. So Wernicke area gets this input. And on the other side, it's facial expressions, and your baby and mother or father make faces back and forth at each other, and you learn facial expressions, and there's a mimicking. You stick your tongue out, the baby sticks the tongue out. You make a grimace face, they make. The back and forth mirroring is teaching emotional recognition, and without that. Early life experience, as Alan Shore has said, you end up with psychopathology. You develop your neural systems and neurotransmitter systems with early life experience, and without that, you're toast.
One of my major issues with what I call iPad in the cradle, the making of an iBaby, is we don't get a lot of those interactions, those little supposedly games like Peekaboo that we play with infants. Those aren't games at all. They're trainings. I mean, again, I could go on and on about this, but it's a major issue in terms of the reduction of those experiences, the potential to mirror and see the emotional development.
I see a lot more of what Les Femi might refer to as open focus. you sit there with alpha in your head, eyes open,
Yeah.
soaking in the information, but not interacting with it in any way.
Yeah.
If you think about it, if you focus on it, if you do anything like that, if your focus isn't just plain wide open, like the perception of a sponge, you're going to end up losing all that alpha. So he taught people how to make lots of alpha and open their focus. And there are a lot of people that sit there in school with an open focus, but they're not really focusing. They're just open, and it's probably a way to be non-defensive in your interaction. And Les did a lot of couples work, and open focus worked really well with couples work. Interacting and keeping your defenses down. You can't have your alpha disappear in the middle of the interaction without being suspect of having it reacted in some way. So they'd focus on you, get you relaxed again, and then restart the interaction. So, but that if you don't end up having a mirror neuron system that's working, you're going to have difficulties. So it's entirely possible that some of the sequestration may have ruined some people's development of their motor neuron, mirror neuron system.
Jane, last night's Q&A, which we have every Wednesday at 6 p.m. Central, 4 p.m. Pacific, we talked about telekinesis, telepathy, because your buddy Elon trademarked those things. And we're in the brain chemical energy business because the brain gives off that chemical energy. Is it possible for another brain to pick up that energy? Like, what is going on? What do you think? Why is he trademarking that? Or what do you think's going on?
Well, that's just all PR. I don't,
So
you
it's
can
not
call it what you
possible?
want. Call it what you want. It'll be what it is. And at this point, they don't demonstrate telekinesis. They don't demonstrate telepathic communication. However, uh, telepathic communication has been experienced by lots of people historically, and it was the reason Berger was interested in the EEG, other than just being a jerk. Yeah, he was a Nazi, stuck thermometers in people's brains that were prisoners, just to see. Anyway, we've got all sorts of history to go back on, and not all of it's good history, and
But how
that's
does that
history.
work? Telekinesis, telepathy, can any of that stuff work?
There's people that focus on those kinds of things and have for quite a long time. Noetic Science Institute here in Northern California. Dean Radin has a book called Real Magic, and he's a scientific person. He's not just it's not just all talk. They actually do experiments and publish them. There are over 200 experiments on presentiment using different biological signals, pupil diameter, electrodermal, event-related potentials, whatever you can measure that can reflect somebody's affective presence and tone can end up responding to the emotional context of what's going on. If you measure those systems for 5 seconds or so, just before a picture is selected by a random number generator, people have an emotionally appropriate reaction to a picture that hasn't even been selected yet. So the future is affecting the present. The telekinesis and all of that are equally odd experiences, but when you think of the future affecting the present, doesn't that kind of twist your mind a little bit?
Yeah, that's why I'm asking the question.
But archetypal memory, you can share a memory. That's what archetypal memories are. Well, what's a memory? Carl Pribram identified, people look for the engram. Where's the memory stored? Do we have a grandmother neuron and a gray neuron, and when they synapse, you have a gray-haired grandmother? We wouldn't have enough neurons. We got a lot of neurons, but we wouldn't have enough to end up having one for everything we need to see. And so, there's a capacity problem, even though we have, bazillions of connections. The difficulty is identifying where things are stored, and they're not stored anywhere. They're stored everywhere. It's holographic, or holonomic is the actual term from Pribram. And you've seen a hologram printed on a plate, a glass plate that has a hologram, and it's three-dimensional. You can kind of see around one side and the other. And if you happen to drop the glass plate and it breaks into 5 pieces, and you pick up a piece, the entire image is there. It's not just the leg of the person who you had an image of. The whole person is there at a slightly smaller resolution. And that's how memory works. If you slowly suck away brain tissue, you don't totally lose the memory, but it gets less and less and less well resolved. So, it's an electrical interference pattern. And your memory, you'd think, well, it's in my brain, and I've got skin here. It's in my memory is enclosed. It's my memory. It's not your memory. It's my memory. Well, in fact, your memory doesn't stop at your skin, and the interference pattern is detectable. You can actually measure these things. Pribram did very careful work. He's a brilliant guy. He worked with animals, and when you try to figure out how you're storing information, you can look at an animal and how they're storing information. Look at a rat's brain, and how do rats sense stuff? Well, their whiskers, a lot of sense in the whiskers. So Pribram hooks up a rat. He sticks the rat's head in a little stereotaxic thing so he can't move his damn head anymore. And then they have a little rotating drum going by the whiskers, and they have different textures and different speeds and things like that. All of the information from the whiskers are being encoded in the brain, and it's a holographic, holonomic style pattern. It's Gabor identified the storage method for holograms, and that's what you see. So very, very detailed in his scientific validation of the apparent theory that was be virtually impossible to study. But that was Carl. He's a brilliant guy. I relate to Carl because he lost a finger as well. I got mine stuck back on, but he had a finger bit by Lucy, his Mac monkey, and he had her for years, and she never did anything like that before. But she had a baby, and he went over to kind of see, and he put his hand on top of the cage, and she bit his finger through the cage because she thought he was trying to grab the baby or something. But he got gangrene and had to have the finger amputated. So he's missing a finger. I'm kind of missing some, and so we're hand buddies, So, but we met years ago at Winterbrain, Key West EEG, and we've been close ever since the first encounter. And
Neurofeedback was made for Key West.
Well, unfortunately, Key West didn't have the facility size. It's appropriate for little meetings, but Key West isn't really set up for a large group. So They moved from Key West to Palm Springs and then to Miami, but they were on the wrong end. I don't know Miami, North Beach, South Beach. One of them is hot and the other one's not. Well, the hotel was co-occupied by Holocaust survivors, so wasn't on the part of the strip that was the active part of the strip. It was kind of the older part of the strip, and but his Rob Call's meetings finally kind of petered out. He's still around, it's an interesting character still, and he's got videotapes and audio tapes and everything of all those meetings. And once in a while, you'll see some of his stuff online. But
Dr. Marie, can you give us an update on your app? What's going on with that?
Yeah, all's going very well. As I said, we have all our data in on the BrainCalm app, so that's for quieting. That's where we pair HRV with our trademark harmonics. Same thing for our sleep app. And we're now getting, all the proof in the pudding on the third one, which is focus. And that is looking just as strong as all the others. And that should be out hopefully in a month or so. We'll see.
How do we get the app?
That's at swinglesonic.com.
And then Jay, while I'm playing around with the app, can you give us an update on Suisun City?
Well, it's coming together nicely. We've got Silvana coming over from Macedonia, from the Macedonian Academy of Arts and Science. She started the Applied Psychophysiology Society in Macedonia. It's part of the International Organization of Psychophysiological Societies at this point. And she was a student of Jordan Popjordanoff, who taught me about quantum effects in the EEG. He was the head of quantum physics for the Soviet Union and ended up in Macedonia when the Soviet Union fell apart. Unfortunately, he passed within the last year or so. Jordan passed. But we've got Silvana coming over to do a talk on paroxysmal activity in autism and ADD, ADHD. She's very well studied, and she's a professor and a PhD. I'm a tech, so she's the expert. We've got obviously Santiago's coming over. He'll be doing a talk. We've got a presentation on AI interfaced with EEG lab to turn out protocols, which would be an interesting presentation. Lisa Tatrin. She's also got a talk on movement disorders, Parkinsonism and movement disorders, and neurofeedback. Lots of interesting talks. Obviously, Lee Steinberg, who's you wouldn't necessarily think of Lee as a neurofeedback person, but he's got a story to tell, and I think tells it well. So we've got him coming in.
And to get information, it's Suisun, SUISUN summit.com to get more information.
And we'll be sending out a save the date probably on the 15th.
Okay.
Beware the Ides of March, So
well, tell the Ides of March to update the website so we can buy in.
Well, they're doing a whole update on the website. They have a webmaster putting the polish on that now, which is why they're shooting for the 15th.
Beautiful.
Obviously it has to be a pay portal for people to be able to register and pay and all that.
Well, of course.
Setting all that up is not quick and easy, that's for sure.
It's not like running a podcast. Jay Gunkelman, Dr. Marie Swingle, another great episode of the NeuroNoodle Neurofeedback Podcast. Thank you and have a great weekend.
Same to you. Bye.
The NeuroNoodle Podcast is supported by listeners and businesses just like you.